Welcome to The Explainer. Today, we're breaking down a pretty radical idea about why people break under pressure. It's a concept called cognitive topology, and it suggests that long before a mind snaps, its hidden architecture is already bending and warping in ways we can't even see. Let's get into it.
So let's kick things off with a question we've all asked ourselves. You see someone, a friend, a coworker, handling incredible amounts of stress for months, maybe even years. They seem totally fine. And then, seemingly out of nowhere, they just snap. How does that happen? Why does it look so sudden?
Well, here's the thing. The core idea we're exploring today is that they don't. That sudden collapse is basically an illusion. What we're actually witnessing is just the final, visible stage, the tip of the iceberg, of a slow-motion failure that's been happening under the surface the entire time.
Okay, so to really wrap our heads around this, we need to look past the surface-level behavior and dig down into the mind's hidden blueprint. And this is exactly where the concept of cognitive topology comes into play.
So what in the world is cognitive topology? Look, it's not about what you're thinking about. It's about the actual shape of the system that's doing the thinking. You can imagine it as the internal geometry of your mind, the fundamental way all the parts are organized and connected. And that structure is what dictates how it's going to handle any kind of pressure or load.
Probably the best analogy for this is a steel skeleton of a building. You never see it, but it's the most important part, right? Well, this cognitive topology is the skeleton of the mind. It's this invisible framework that determines how pressure moves through the system, where it's going to build up, and what is most likely, or maybe even inevitable, to happen next.
And this is a really important distinction to make. We love to talk about things like personality or mindset or different coping styles. But according to this model, those things aren't the structure itself. Nope. They're just the expressions of that deeper topology. They're like the paint on the walls, not the foundation or the steel beams holding the whole thing together.
Okay, so if our mind has this kind of fundamental structure, how does it actually bend, or warp, or even break when it gets put under serious stress? Let's dive into the mechanics of it.
It pretty much boils down to these three key factors. First up, you've got pathway width. Think about it. Are the pathways for stress wide, so the load can spread out and dissipate? Or are they really narrow, creating these dangerous pressure points? Second, there's network connectivity. Is the whole system highly connected, so the burden is shared across a lot of different points? Or is it sparse, leaving some parts to handle the stress all on their own? And finally, you have structural alignment. Are the parts of the structure lined up in a way that channels pressure safely, or are they misaligned, creating critical weak spots?
And all of this leads to three basic ways that topology can react to load. You've got an elastic one. It's flexible. It bends under pressure, but then it bounces right back to its original shape. Then there's plastic. It also bends, but it stays bent. The structure's permanently reshaped. And finally, you have the fragmentation topology. This one is brittle. It doesn't really bend at all. It just fractures and shatters into pieces. And the big insight here is that these aren't just psychological labels, They're described as architectural realities.
All right, so we've got these different types of structures, but here's the catch. No matter what type of system you have, every single complex structure has weak points, and understanding this is absolutely critical.
So, the first kind of weak point is the bottleneck. I mean, just picture a highway where 5 lanes suddenly have to merge into one. All that pressure has to squeeze through one tiny spot because there's just nowhere else for it to go. This is where the pressure naturally builds up, it's where the deformation is guaranteed to start, and it's what makes the sequence of a breakdown surprisingly predictable.
And then you have structural fault lines. You can think of these like tiny, invisible cracks in the foundation of a building. Under normal, everyday conditions, you'd never even know they were there. But as you start to pile on the load, those hidden cracks activate, and they start to rupture.
And this all leads to one single crucial point. Breakdowns are not random events. They are a direct mechanical consequence of the system's pre-existing shape. A system doesn't just break. It breaks exactly where its own design has shaped it to break.
Okay, get ready because this brings us to what might just be the most mind-bending idea in this entire framework, a total reimagining of what identity even is.
The argument here is incredibly bold. It says that your identity is not the story you tell about yourself. It's not your beliefs or your memories. It is simply the structural continuity, the stable, consistent shape of your particular mental topology over time. That's it.
I mean, just think about that for a second. That is a total game changer. It means that when the underlying mental structure starts to deform, our very sense of self, our identity, deforms right along with it. And when that structure finally breaks, identity breaks. This gives us a whole new way to understand why two people can go through the exact same pressure and have wildly different outcomes. Their underlying architectures, their actual identities, are just built differently from the ground up.
So now we can finally map out that whole invisible path to collapse. It all starts way before anyone sees anything, with the system's internal stability just draining away. Then those hidden fault lines start to activate. Next, the bottlenecks get completely overloaded, as the pressure has nowhere else to go. The pathways for distributing that stress get narrower and narrower. And only at the very, very end of this long chain reaction do we get to stage 5, the observable collapse, the thing we see and mistake for a sudden snap.
So let's just bust that myth we started with once and for all. Systems don't snap. People don't snap. They reach the predictable, almost mathematical end of a deformation sequence. The collapse was basically baked into the architecture from the very beginning.
And let's end on this final, really provocative thought. Under pressure, a system doesn't rise to its capability. It falls to its topology. In the end, it's not defined by its potential or its strengths. Ultimately, its fate is sealed by its weakest points, by its very structure. So the real question this leaves us with is, what shape is your system built to hold?